Right, okay, for our next example, we're going to be having a look at the power node, or exponentials. So I'm using the inbuilt function here, debug scalar values. If you just type in debug, if you spell it correctly, debug scalar values. You can debug float values, you can debug on, off, time sign. There's lots of debug functions built into the engine for us. And you might see here that I have adjusted the values. Oh, number of digits adjusted to 4. So this is going to take our input number and then using a text sample, it's going to convert that into a readable set of numbers. And the default input, if I can find it, lower left, no, maximum number of digits. The maximum number of digits here up on the top is set at 8. Which, if we have a look, is quite a lot of information. So I'm just going to knock that down to 4 and then save, just to make things a bit clearer and easier to read. Obviously, if you are editing the inbuilt engine examples, just be careful what you're doing, make sure you don't break things, but you can always update your engine and get back to the default. But yeah, my personal sort of experience, 8 is far too high. 4 makes much more sense. So I've just adjusted that and then obviously made this note here. Okay, so the power node, if we remember from sort of school, powering something is multiplying something by itself a number of times. So 3 to the power of 2 is 3 times 3. Well, 3 times 3 we know is 9. But if we wanted to do that again, we'd have another multiply and then multiply by itself again. And now we're going to get 27. It gets quite expensive or quite long-winded. And what happens if we don't know how many times we want to multiply by ourselves? What happens if that's a variable? Well, we can't really do that. And so we have this term, or this mathematical operator called power. Let me just clean that up slightly. And so here, 3 to the power of 4. And if I just swap the preview over, that's going to give us the same value. So we're multiplying the number by itself a number of times that we have fixed, and that's what's called the exponential, the exp here. Shortcut for the power node is e-click, e for exponential, and we'll get that multiplication or that operation. Okay, well, that's useful. That's the math behind it, but how is that useful to us as artists? Well, if we have a texture where everything is already a black and white value between 0 and 1, we can use a power command or a power function, power operation, as a contrast. So if I plug in a value of 1, anything multiplied by itself once is itself. So 1 is what I've called the do nothing point. Sometimes with different operations, the do nothing point is sometimes 0, sometimes it's 1. If we're adding, the do nothing is 0. If it's multiplying, the do nothing is 1. If we're powering, the do nothing is going to be 1 again. But if I plug in a value of 2, now we get a bit more dark. The dark areas get darker. 4, 8. And you can see we're adding a lot of contrast to our texture. Similarly, if we want to reduce the contrast, we can use values less than 1. So 0.2, 0.5. It's a little bit less accurate. There's some loss of accuracy in the numbers, but it does work. But contrasting up definitely works quite nicely. Now, why is this happening? Well, if we think about the values and what we have in here, I might just grab this setup. So if I start with a value of 0.1, so I start with a value that's very low and very dark, then the value I'm going to get is going to be really, really small. So small I can't even see it in here because my number of digits is too low. Let's make that 5. That should work. There we go. So if we start with 0.1, a very low value, and we power it by 4, we're going to end up with a really, really, really small value. If we do the same setup, but with a starting value of, let's say, 0.9, something much higher, nearer the whites, when I power that by 4, well, I've still got quite a big number. And so the relative change in the values is different. So the darker an image, or the darker a value starts, the darker a pixel starts, the darker it gets, or the quicker it gets even darker with higher power numbers. And that's why we're getting this contrasting effect. So here, obviously the darker pixels are these ones in the middle of the cells, and so they are going to get darker quicker, and then the lighter values, the closer to 1, they're going to get darker slower, and so we get more contrast. Note, it's worth noting, anything to the power of anything, well, here we go, 0 to the power of anything will always give us 0, so our black point in our image is always going to be fixed, and similarly 1. So 1 to the power of anything is always going to give us 1. So as long as our input range is fixed between 0 and 1, no matter what we do to power it, we're only changing the middle. This is very similar to levels in Photoshop, if you've used that, or similar histogram scan, I think, in Substance. So we're using this as a sort of way of changing the contrast. Okay, really useful. Worth noting, it is a little bit more expensive than, say, multiplies. If we were just wanting to add contrast as a one-time operation, you might see this just multiply by itself and then carry on. That would be a slightly cheaper operation than powering. Again, I believe, although don't quote me on this, that Unreal will compile this correctly. So if you're powering by 2, it will work that out and compile down to a multiply. If you're powering by something like 2.25, Unreal can't work that out as a multiply chain, and so we'll have to use a power, but I'm not 100% sure on the compilation of that, but interesting to know. Okay, that's the power node, and next we'll be moving on to some trigonometry and some animation.